All right, here we are on section 7.2. You see, when you were in class, we would have had a homework check, and I wanted to show you this first question story problem here. The perimeter of a living room is 64 feet, so that's a perimeter in there. And the ratio of the length to the width, so my perimeter is 64, and the length to the width is 3 to 5. And again, this is like the extended one we did in 7.1 with the angles. I could take 3 and 5, that ratio and go, oh, 6 to 10 and 9 to 15 until I got to 64. Or I can say, hey, I want to find out what each of those is. So I'm going to say that I know that 3x plus 5x plus 3x plus 5x, because if you're finding the perimeter, you need all of the sides, at some point is going to be equal to 64. So I'm going to add that together and get 16x equals 64, x must be 4. So I know that my living room is going to be 3 times x is 12 feet, and by 20 feet. Most common mistake with that one is people forget that in the perimeter you have 2 lengths and 2 widths. Alright, so let's get started on this quick check. It says there is a 480 sophomores and 520 juniors in high school. Find the ratio of juniors to sophomores. Well, notice that juniors is said first, so it goes on top. So I get that, and of course we can simplify that down to 13/12 by dividing by 40. A strip of wood molding is 33 inches long, is cut into 2 pieces whose lengths are in the ratio of 7 to 4. What are the lengths of the 2 pieces? So we know here that 7 times something plus 4 times something equals that 33 inches. And if I simplify that down, I know that my x is 3, but that doesn't tell me the lengths. I know that the ratio is 7 times 3, or 21, and 4 times 3, which is 12. So it's 21 inch for one piece and 12 inches for the other piece. Let's do our cross products here. I get 72x equals 504 maybe. And then if I divide, I'm going to need a calculator here, gives me 7. Now another way to do this, if you notice that the top and the bottom are both divisible by 12, I get 6 over 7. Well, 6 is to 6 is 7 is to x. If you can simplify first, please do. Alright. More of the same, just use your calculator. Let's do one of these. If I do the cross products, I get 8 times the quantity of 2x minus 1 equals 4 times the quantity x plus 4. Remember, put it in parentheses because you have to distribute it to both of them. Giving you 16x minus 8 equals 4x plus 16. Subtracting 4x from both sides, I get 12x. Adding 8 to both sides gives me 24, so x equals 2. So, good review. What we're going to do in section 2 here is we're going to use similarity to do some solving, basically. And these are dilations. And similarity, transformation, scale factors. You can see why we put these two sections together, because they're so similar. Again, back to this stuff. I know it's review, but you have to put them in the same units before you can simplify. Here we have a triangle, and we know that they're similar, and we want to find GK. So we know the proportion is going to be HJ is to JL, which is 12, as GK is to KL. And we're going to do our cross products there and get 12x equals 60, so x must be 5 in this case. If I have a 10 by 8 photo that must be reduced to a length of 5.5 inches, what will the resulting width be? So if I know length to width, so I'm going to write it this way out front, so you guys see that I'm continuing to do length as to width as length as to width. And if I do some of the cross products here, I get 5.5 times 8 gives me a 44 equals 10W. So my W must be 4.4 inches. Determine whether the given polygons are similar. To be similar, all the sides have to be in the same ratio. So 1 is to 3 as 1 is to 3 as 1 is to 3 as 1 is to 3. So the ratio for all of them are in the same ratio. All the sides have the same ratio. So the ratio is 1 to 3. When we're doing this, we have to ask ourselves, are the polygons the same shape? Well, in this case, they were both squares. Will the transformation map one polygon onto the other? Is one polygon a scale factor of the other? And are the polygons similar? Well, if these are all yes, then we know that they are similar polygons. So if I look at this one, I have a side ratio of, this side here is 1.5, this side is 1.5 down here. So we know that those two sides are, but the vertical line over here is 2 and the vertical line over here is 3. So over here it was a 1.5 to a 1.5 ratio. And here it's 2 to 3. They are not the same ratio because every side ratio has to be the same. Let's check these two polygons to see if they are similar. What we need to do here is we need to check is 15 is to 5. That would be a 3 to 1 ratio, simplifying it down. 12 is to 4 is a 3 to 1 ratio. 21 to 7 is a 3 to 1 ratio. 18 to 6 is a 3 to 1 ratio. So all the sides are in the same ratio. So yes, those are similar. If angle ABC is similar to angle RST, list all the pairs. I think they're talking triangles. List all the pairs of congruent angles and write a proportion. Now, when we say, just like when we said triangles are congruent, we said it meant 6 pieces of information. Well, when you say triangles are similar, it means that 3 angles are congruent. Angle A is congruent to angle R. Angle B is congruent to angle S. And angle C is congruent to angle T. So the angles stay congruent, even if they're similar. What changes is the side ratio. So we know that the side ratios have to be the same. So we would say that AB is to RS as BC is to ST as CA is to TR. Those two, all three of those ratios have to be the same. So here is the proportion about their sides. Okay? In this one, we're saying if they're similar, then we know that the 8 is to the y plus 1, and we know that the x is to the 3 as 6 is to 4. So let's solve some of these and see. There's only one of the sides that we know both of the numbers, and that's going to be true for all the problems. And when I set up my proportions, I'm always, the top one is further to the left, the bottom one is the one further to the right. That's going to be true as 8 is to y plus 1. You can solve that. To find the x, we're going to say 6 is to 4 as x is to 3, and you can solve that also. And those are how you set it up. Now, if you want to set it up as top is to bottom, then you're going to write 4 is to 6. But as long as you stay consistent, remember, all the lengths from this picture have to be in the same position as all the ones in this one. Okay? Keep them in the same position, make it, set it up easier. All right. So just like we did back in when we were proving congruence and when we were talking about segments and we were talking about angles, we have the reflexive, symmetric, and transitive properties of similarity. So some things never change, do they? So we have a first theorem says the perimeter of similar polygons. So if I add up all the sides of one polygon and I add up the sides of another polygon, let's say that the ratio of one of them is 3 to 2, and they are similar, then we know that the perimeter is going to be the same ratio. It's going to be similar to the other ones. So if you know the ratio of two sides and you know the perimeter of one, you can find the perimeter of the other. Make sure you get this down on your blue sheet. And I believe that is the end of my lesson. Have a great day.